and it's a hey from West Virginia. Never mind. Anyways, let's get to joke of the day, because you know we've got joke of the day, right? And it is the best part of the day, and I know you've been waiting, so here it comes. You know, parallel lines, they have so much in common. It's a shame they'll never meet. That's one of my favorites. And how timely, because look, we're going to be talking about parallel lines. We're going to talk today about slopes of parallel and perpendicular lines. Now, notice that what I've got here is a couple of illustrations that are going to help us to understand why these slopes are the way they are. So take a look first at this idea of parallel lines. What I did was I laid a parallel, or a line down here. This is a line we've previously looked at with coordinates of 6, 4, and -6, -4. We looked at that in the previous video. And I've labeled my lines. You can label lines with the points, or you can label them with lowercase cursive letters. So I've got a lowercase l here. Now, tell me what you know about parallel lines. Parallel lines, they never intersect. Yes, they never intersect. So we've got a couple of parallel lines. They are definitely parallel because, not so much on here you can see I didn't even draw a straight line here because I'm not very good at it. But in my notes when I did this, I drew the line with a ruler. And then what I did was I took that ruler and measured out the distance between the two lines all the way like this, drew that second line and said, okay, where does it hit? And it hit at the point 0, 2 and -3, 0. So I can tell you, in fact, these really are supposed to be parallel to each other because the distance between them is the same all the way across, and therefore, because of that, they are never going to intersect each other. Now, I want to take a look at the slopes of these lines. This line L, we've already looked at its slope in the previous video. Now remember, you can use that formula for slope if you would like, but when you have a picture, you can use that counting tool, rise over run. So we utilized rise over run in the previous video, and we said we're going to go up 4 and then we're going to go up 4 again, and because we went up, that's a total of 8. And then we said once we go up 8, we're going to come across 6 and we're going to go across 6 again, and because we went to the right, that gives us a total of 12, or sorry, to the right means positive, and we always simplify a fraction if we can. 4 goes into both of these, 8 and 12, and that simplifies to a 2/3. Now let's take a look at our line M and get its slope. Once again, because we have a picture, we can utilize rise over run. So we're going to come up 2, and because we went up, it's positive. We're going to come across 3, and because we went to the right, it's also positive. Now, compare the two slopes. Yes, they are the same. And that's going to happen every single time that you have parallel lines. They will always have the same slope. Think about it. If slope, as I previously told you, is the tilt of the line, and if these two lines are never going to intersect, then it would stand to reason they have to have the same tilt. Because if they are going to intersect, if they have a different tilt, and it's off by even just a little bit, eventually somewhere they're going to intersect. So for them to never intersect, they're going to have the same tilt. If they had different tilts, they would intersect eventually. So that means that parallel lines have the same tilt, and that tilt is the slope. So it stands to reason that parallel lines will have the same slope. Now let's take a look at perpendicular lines. Let's go with that previous line L with the points of 6, 4 and -6, -4. We've already figured out that its slope is 2/3. Now let's compare a new line, line N, that's right, the line N here. Now, again, what I did in my notes, this is not very good, but what I did in my notes was I drew line L and then I laid a protractor down, because what do you know about perpendicular lines? Yes, perpendicular lines intersect at 90-degree angles. Intersect at 90-degree angles. So what I did was I laid a protractor down here on line L, and I went up 90 degrees and drew that line. And you can see this is a pretty good 90-degree angle right here. Now, I figured out, okay, where does that line N hit? And it hit at the point -2, 3 and 2, -3. Now let's figure out the slope of that line. Well, to go from this point to this point, we have to come down 3 and down another 3. Since we're going down, that's negative. And we went down a total of 6. Now once we went down 6, we came across 2 and across 2 again. That's a total of 4. And because we went to the right, it's going to be positive. And you know that you always simplify fractions if you can. This simplifies to a -3/2, because the number 2 will go into each one of those. Now, compare these two slopes. Yes, they have opposite signs. One's a positive, one's a negative. And what else do you notice? Yes, you can take this one and flip it. So we have opposite reciprocals. Opposite is what changes the signs. Reciprocal is the idea of flipping your fraction. This will happen every single time that you have perpendicular lines. You will always have opposite reciprocal slopes. Again, opposite changes the sign, reciprocal flips it. And once again, if you think about it, this kind of makes sense. I mean, it's not as intuitive as your parallel lines is, but think about what happens here. Remember the skier, and remember that the skier, when he went on one like this, it was a puff, puff, positive. So this is going to have a positive slope. For them to intersect at 90-degree angles, the other one's going to have to tilt in the other direction. That is nice negative. So it makes sense that they are going to have opposite signs in order to make that 90-degree angle. Now, that's your opposite signs. Think about the reciprocal concept. When I take this line and then I make it like this line, do you see how I'm flipping my arm over? And that flipping is the reciprocal concept. And that is how you get opposite reciprocal slopes. Now, let's take these slopes, this 2/3 on line L, and this -3/2 on line N, and let's multiply the two together. Remember, whenever you multiply fractions, you are still in my math gang. When we multiply fractions, we cancel on those diagonals, we cancel up and down, and then we shoot straight across. And notice what happens here. The 2's cancel completely, the 3's cancel completely. I am left with a 1 times a -1. And what is 1 times -1? A -1. This will happen every single time that you have perpendicular lines. The product of their slopes, when you multiply the slopes together, you will get a -1. And again, this kind of makes sense. Think about it. If they are going to have opposite signs, when you multiply a positive times a negative, you're going to get a negative every time. And if you have reciprocals and you take one and you flip the other, then it makes sense that once you flip it, those diagonals will definitely cancel out and you're going to have a 1 out of that. And that will happen every single time that you have your perpendicular lines. The product will be a -1. So now let's take a look at some examples. And what we're going to do in these examples is we're going to compute slopes and we're going to compare them. Okay, so now let's take a look at some things that we can do with these ideas of perpendicular lines having opposite reciprocal slopes and parallel lines having the same slope. So in these examples, what we're going to do is determine whether the lines are parallel or perpendicular to each other, or maybe they're neither of those cases. So what we have to do, notice that we've got a line that goes through the point 0,3 and the point -20. We're going to get the slope of that line, and then we're going to take the line that goes through 3, 2, and -1, -4, get that slope. We're going to compare the two. And if they are the same, they have to be parallel lines. If they're opposite reciprocals of each other, well, then they are going to be perpendicular lines. And if it's neither one of those cases, then they're neither perpendicular or parallel, neither case. So let's take that first line and let's get its slope. And notice here that we don't have a picture, so we have to utilize that formula for slope. Recall that the formula for slope is y2 minus y1 over x2 minus x1. And remember, I told you before in a previous video, it does not matter the order you subtract the y's. Just make sure you go in the same order on those x's. Whatever order you designate for the y's, you have to go in the same order for the x's. So let's say that I choose for this one, I'm going to do a 3 minus 0 for my y's. Well then, since I did first one minus second one, that means I have to do first one minus second one for the x's, so it'll have to be 0 minus a -2. Now you know that subtracting a negative is really adding a positive. So when I subtract on that numerator, 3 minus 0 is 3, and on that denominator, 0 plus 2 is 2. So I get a slope of 3/2. Now let's take a look at the slope for the other line. Once again, I'm going to utilize that formula for slope, and I'm going to do, let's subtract the y's on the numerator, and I'm going to do 2 minus a -4. Now, since I went in that order, 2 minus a -4, I have to go in the same order for the x's, 3 minus a -1. And just like we said before, subtracting a negative is really adding a positive. So 2 plus 4 will give me 6. And then 3 plus 1 will give me 4. And like we said before, always simplify a fraction if you can. Is there a number that will go into both of these? Yeah, like we saw before. 6 over 4 reduces or simplifies to a 3/2. Now, compare those two slopes. They are the same. So when they are the same, what does that tell me about these two lines? Same slope being tilt. That means these are going to be parallel lines. Okay, let's try the next one. So in this one, similar idea, I need to be able to get the slope of each one of those lines, and then I'm going to compare it to decide if they're parallel, perpendicular, or neither. So I'm going to subtract the y's on the numerator, and let's go with the -1 minus the -8. I could do it the other order if I wanted, it doesn't matter, but since I went in that order, the x's will have to be 4 minus the -2. And like we said before, subtracting a negative is really adding a positive. So that I have a -1 plus 8, which is 7, and 4 plus 2 will give me 6. So there's the slope for the first line, 7, 6. That does not simplify. Now let's check the slope for the second one. Doing the very same idea, let's subtract those y's on the numerator, and I'll go 2 minus the -2. And on that denominator, if I went 2 minus the -2, I have to go -3 minus 5. And like we said before, subtracting a negative is really adding a positive. So 2 plus 2 will give me 4. And -3 minus 5 is a -8. That simplifies to a -1/2. Now compare those two slopes. They are not the same, so it's definitely not parallel lines. And can I take this one and flip it? Now notice they do have opposite signs. This is positive, this is negative. But can I flip this one to get that one? Absolutely not. And I have to have opposite reciprocals, both conditions for them to be perpendicular lines. So therefore, that means this is neither parallel nor perpendicular. It's neither case. There are definitely a couple of lines, no doubt about that. But there's nothing special about them. Okay, let's try another one here. So in this case, similar idea. I'm going to calculate those slopes and compare them. So let's do a 5 minus 8. Could have done 8 minus 5, it doesn't matter. But if I do 5 minus 8, I have to do 4 minus 5. And 5 minus 8 is a -3. 4 minus 5 is a -1. And that simplifies to a -3. Now let's take a look at the second one here. And I'm going to do -3 minus -2. And if I have to go that order, it has to be 3 minus 0. And like we keep saying, subtracting a negative is really adding a positive. So -3 plus 2 is a -1. And 3 minus 0 is 3. Okay. Notice that. Hold on. Oh, goodness gracious. Okay. Negative divided by negative is positive. So we get a +3 there. My deepest apologies. So notice that they do have opposite signs here. One's positive, one's negative. And notice that if I take this one and I flip it, it becomes a 3. So I do have opposite reciprocals here. And if I have opposite reciprocals, what types of lines are they? Yes, they are perpendicular lines. All right, one more. And then we'll take a look at another case of trying to determine whether they're parallel or perpendicular. So we'll get the slopes for each. And we'll subtract those y's on the numerator, and this time I'll do 7 minus 3. And on that denominator, if I do 7 minus 3, it has to go this one minus this one on the x's, but notice -12 minus a -12, they're the same thing. And like we keep saying, subtracting a negative is really adding a positive. So on that numerator, 7 minus 3 is 4, and on that denominator, they cancel out to be a 0. Now when 0 is in the denominator of your fraction, what does that indicate? Yes, that indicates undefined. Now, remember, if you're confused about this, the numerator of your fraction tells you how many objects you have to pass out. The denominator tells you how many are out there to receive it. So this would say that I have 4 markers to pass out. This says there's nobody out there to receive them. So I'm trying to pass them out. I'm giving it my best, but there's nobody out there to receive the markers. And if there's nobody to receive them, I cannot make the action happen. It is an undefined action because I can't make it happen. So now let's take a look at this one. And once again, we will subtract those y's on the numerator. We'll do 3 minus 3. They're the same thing. And on that denominator, it doesn't really matter what order I go because on that numerator, I'm going to have a 0. Now, yes, on the denominator, subtracting a negative is really adding a positive, and I do get a 10. But when 0 is in the numerator, what does that indicate? Remember, this one says I don't have any markers to pass out, but there's 10 people out there to receive them. So how many markers will each person get? Each person gets 0 markers. So we've got undefined and we've got 0. Now, let's think about this. We want to know, are they parallel, are they perpendicular, or are they neither? Think about what's happening here. Do they have the same slope? Because if they have the same slope, then they're going to be parallel. No, these are definitely not the same thing, no doubt about it. So either they're perpendicular or they're neither. Now, go back to the idea of the skier. Remember with that skier, we had our puff, puff, positive, we had our nice negative, and then what happened right here? Remember, he was taking a nap, and the z's represented 0 slope. So this is going to be a horizontal line right here. Then remember, the skier came to that cliff, was falling off the cliff, and was going to be undefined in the end, as horrible as that is, but it helps us remember. So remember, that vertical line had undefined slope. This is a vertical line. So we have a vertical line here, a horizontal line. Well, if you have a perfectly horizontal and a perfectly vertical line, what do you know about them? Yes, they are perpendicular to each other. So these two are going to be perpendicular lines. And what that indicates is that whenever you have undefined and you have 0, they really are reciprocals of each other, because if you flip this, that puts the 0 in the numerator. If you flip this, it puts the 0 in the denominator. Now, granted, that would put a 4 down here and a 10 up here, but the bottom line is this: undefined and 0 are reciprocals of each other. And these are perpendicular lines because you've got your vertical line here and your horizontal line here. Okay, so like I said, we're going to get a couple other examples of determining whether you have parallel, perpendicular, or neither, but different styles of figuring that out. Okay, so what we're going to do in these last examples is we're going to determine whether the pair of lines that are represented by the equations are parallel, perpendicular, or neither. So you'll notice here that I've got a couple of equations, and I've told you before that the equation is the name of the line. And so I have a line here and I have a line here with each of those names. I'm going to try to determine whether this pair of lines is parallel, perpendicular, or neither. The same thing here, same thing here. Now, the only thing that we know is that parallel lines have same slope, perpendicular lines have opposite reciprocal slopes. And if you don't match either of those cases, then the lines are neither. They're definitely there, but they're neither parallel nor perpendicular. So what I have to do is take this equation, I have to figure out the slope of that line, and the same idea for this equation. How are we going to get slope when we have the equation of a line? Yes, what we have is the slope-intercept form of the equation of the line. Remember, slope-intercept form looks like this: y equals mx plus b. And when you have it in that form, your slope is going to sit right there in front of that x. Now the question is, how do you know that you're in that form? Yes, that means that the y is by itself. That's the key. You need to take each of these equations, you need to rearrange them to get the y by itself. And when you have the y by itself, your slope will sit right there in front of that x. So, let's take the first one, and in order to get that y by itself, what I'm going to need to do is subtract that 3x from both sides. Now remember, sign in front's a sign that goes. You keep that name tag on the front when you go to the meeting. When you go to a meeting, you don't put your name tag on the back because I don't know who you are. You put your name tag on the front so that I can identify you with your face, and I know that's who you are. Sign in front's the sign that goes. That's the name tag for the number. So this is a negative 2y that's sitting there, and when I subtract that 3x, I'll get a negative 3x and a positive 6 plus 6. Now I'm going to go through and I'm going to divide every single term by that negative 2, and that will give me y equals negative divided by negative is positive, and I get a 3/2 x minus 3. So the slope for this line is going to be that 3/2. Now I need to do the same thing with this second one, and then I'll be able to determine whether they're parallel, perpendicular, or neither. So to get this y by itself, I'm going to subtract the 2x. That will leave me with 3y equals negative 2x plus 3. And now what I'm going to do is divide every single term by a 3. And that will give me y equals negative 2/3 x plus 1. And here's what I'm concerned about, the slope of that line. I'm going to compare these two slopes to determine whether these two lines are parallel, perpendicular, or neither. Notice that if I take this one and I flip it, I get the 2/3. And what do you notice about their signs? Yes, they are opposite signs. So since these are opposite reciprocals, what types of lines are they? Yes, they are perpendicular. Opposite reciprocal slopes means perpendicular lines. All right, let's try it out for the next one. So what I'm going to do yet again here is I'm going to take this one, I'm going to rearrange it and get the y by itself. I'm going to subtract that 8x. Remember, that leaves me with a negative 9y because the sign in front's a sign that goes. And when I subtract that 8x over here, I get a negative 8x plus 6. And now I'm going to go through and divide by a negative 9 on every single term. And that will give me y equals negative divided by negative is positive, so I get a positive 8/9 x. And then here, positive divided by negative is negative. 6/9 does simplify because 3 goes into each one of these and it simplifies to 2/3. But really, the big deal is right here. The number in front of the x is the slope. So the slope for this line is 8/9. Now let's get the slope for this line. And what I'm going to do once again is I'm going to subtract that 8x, giving me 6y equals negative 8x minus 5. Now I'm going to go through and I'm going to divide by 6 on every single term. That will give me y equals negative divided by positive is negative. Now let's simplify those fractions. 8/6 simplifies to 2 goes in each one of those, 4/3. And here I get a negative 5/6. And this is the important part right there. The number in front of the x is the slope. Now compare these two slopes. They do have opposite signs. That's good. Can I take this one and flip it and become 8/9? No. Now here's the thing. If I flip it, it becomes 3/4, a negative 3/4. And you may be thinking, well, now hold on a second. You may be thinking 2 times 4 is 8, but 3 times 3 is 9. But remember, for them to be perpendicular, I have to be able to flip it and change the sign. I can't make that happen. And they're not the same slope. Same slope would indicate parallel lines. So therefore, what do we know about these? They are neither. Neither parallel nor perpendicular. A couple of nice lines, yeah, but neither parallel nor perpendicular. All right, one last one. So we're going to take this one, we're going to rearrange it. Once again, we're going to subtract that 2x off, giving me 5y equals negative 2x plus 4. We're going to go through and divide every single term by 5. That will give me y equals negative 2/5 x plus 4/5. And the important part is sitting right here with that slope. And now we're going to take this one and we're going to do the very same thing. We're going to get that y by itself by subtracting that 4x off, giving me negative 4x plus 1. I'm going to divide through by 10 on every single term. And that will give me y equals negative divided by positive is negative, and that fraction simplifies because both of those numerator and denominators are divisible by 2. So I get a negative 2/5 x plus 1/10. And the important part again is right here in front of that x. Compare these two slopes. Aha, yeah, they are the same. And remember, when they're the same tilt indicates parallel lines. So, I hope that this helps with the idea of parallel and perpendicular lines and being able to determine whether you've got a couple of points on a line or whether you've got an equation to represent the line, being able to determine whether your pair of lines are parallel, perpendicular, or neither. Remember, you need to get those slopes and compare them. Parallel lines will always have same slope, and perpendicular lines will always have opposite reciprocal slopes. I hope that helps. Have a great day.